Good afternoon. Thank you. So what should we do? Should we do the Coot and PyMOL things first, and then look at what I talked about this morning? Is that what you have in mind? No response.
PyMOL and Coot, right? You can do that. They will do PyMOL and Coot.
First?
Yeah, first.
Okay. Okay with me. Okay. Then let's do Coot first. So you saw the primer I wrote as Professor Shukla shared with you, right? So did you have a chance to practice a little bit with that yesterday? Was that useful? The primer? All right. Okay. Let's get started. So my folder has more files than yours, but that's okay. We're using the same files, okay? So just start Coot. So as you saw yesterday, Coot opens a lot of windows. That's why when I start Coot, I always put the window on the right a little bit. So leave space on the left so that any window Coot opens up, I drag it to the left so that it doesn't disappear behind this graphics window. Now you can't find it, or you have to close this window to find it. So that's what I always do that. Okay, so let's open the PDB file. Okay, let me. Okay, you should have something like this. And then change the color again, edit bound color, go back to 0. Okay? And then let's open the electron density. So, right, let's 0,1 to MPTZ, right? That's what you have as well. So one thing I did not mention yesterday is the contour level of this cage that you have here is controlled as well. So that you do by rotating the middle mouse wheel. You see something show up at the top corner. So this is 1.3 RMSD. You see that on, I don't know what it is on your screen, but there's a number up there. So we'll make that 1. So just turn your mouse until it's 1, within close to 1, let's say. This one exactly 1.00. Okay? So that changes the contour level. You can play with that and see the contour level. You see the density change. You make it very high, everything disappears. If it's too low, then you're looking into the noise. So that's the idea. And then we'll go Display Manager, drag to the left, Properties, Color. I'm gonna make it brighter so we can see it. And then if you have a larger radius, that's shown here. I have 7 angstrom. When you have a larger radius, then you can change that as well. Edit, map parameters. And there you can set whatever radius you want to set. I set it to 7. So far, so good?
So how to change the radius?
I'm sorry?
How to change the radius?
How to?
Change the radius.
The radius of the map? Yeah, so edit, map parameters. And then the first one, map radius X-ray, 7. So put in 7 up or whatever number you like, and then that'll change, and then say OK. Did that work?
Yes.
Good. So, all right. So everybody's on the same page now? Yes. Okay, so now we need to start building. So to build, you go through one by one. You don't have a preference. You don't have a favorite child or whatever. You go through one by one. So to go to the first residue, I showed you can use the little pull down menu, all that stuff. But then for the very first residue, you just push the space bar. And that gets you the first residue. In this case, the first residue is Valine 2. You may remember from yesterday, right? You can sort of see this is the Valine 2. That's labeled. The density, the waters you see here as well from yesterday. Okay? So now, what we do, we build in a residue. So add terminal residue right here. You can add a residue to it. And then click on anywhere on the valine, you get another residue built in, which is the alanine. And then you can do shift space bar. That goes back one residue. So then it goes back to the residue we just built, which is alanine 1. Please speak up if you are falling behind. Okay. Are we still okay? All right. So as we discussed yesterday, there should be a lysine. So then we can do a mutate. So simple mutate, which is right here, right above add terminal residue. And then click on the alanine. You get the menu. Yeah. And then that's alphabetical, so you select lysine. I'll leave this up there for a little while. So do you know where we are, or where are you actually? Oh, you don't have the map yet. Okay. So open the map. So that's a file. Open, auto open MTZ. Did you do auto? Yeah, like that one. Yeah. Say OK. No, file. No, this one. File. No, yeah, under file. Auto open MTZ. Yeah, right. There you go.
MTG.
Yeah. And say OK. Yeah. And then the map radius is too big, so edit. Map parameters. Yeah, make that 7. So the first number. Make that, no, yeah, make that 7. And say OK. And then spacebar. That gives you the residue 1. And then you change the control level, scroll. No, you don't have a mouse. So, yeah, right here, you can see the number up there. So make that 1. Go ahead. Yeah, front is better. Make that 1-ish. Yeah. So now, can you zoom in? Zoom up a little bit? Oh, you're good at trackpad. That's great. OK. Zoom in a little bit. You can see the valine. Right? Zoom in more. Yeah, there you go. See, and that's the actual density right there. Yeah. So then you add the terminal residue, or you don't have the menu, or you have only icons. Good. Are you good at Coot? You're very good at using Coot?
Yes.
Oh, I'm sorry. OK. So everybody has something like this? All right. Okay, so we'll select lysine. So now we have a lysine built in. The side-chains are the density. Oh, you're not in the first residue. So go to push spacebar, see what happens. There you go. No, once, not too many times. Which residue is that? I can't read the label. What does the label say? Yeah, you had to go back. So no. Shift spacebar, go back. No, hold shift down and then space at the same time. You should go back. No, shift space. See, now you're variant 2 now, right? Which residue is that?
This one is the arginine.
Which residue number? I can't see.
This is 45. Arginine.
Okay,
45.
that's not it. Okay, so why don't you don't do that? Why don't you go to the arrow up here, the toolbar, this thing, the green one. Click on that. Go to residue 2. Select residue 2. Residue number, yeah. You can put the number 2 here.
2.
Yeah,
Okay.
and then say accept. There you go. You should be there.
This is leucine. This one is leucine. 56.
No, it should be 2. No. Residue 2, not chain 2.
Chain is Z.
Use the drop down menu. Click on this arrow there.
This one.
Okay? And then you see 2 there. Click on that. You see 2?
This is 2.
A2, yeah, A2. Click on A2.
Yes.
And then say accept. There you go. Okay? Right here.
Yes.
Okay? No? All right.
Add terminal residue and shift.
But so go here.
Here.
And then
Chain.
open this, and then click on 2.
2.
There you go. Say accept.
Apply.
Yeah, you're there. Okay.
Add 2 terminal residue.
Add terminal residue. That's right. So, yeah. All right. So I guess a few of you may not be in the right place. May not be in the right residue. Is that true? How many are not in the right residue? Speak up, please. You're not at this place. Okay. So let's try this. Everybody, please look at this. Okay. So under draw. Okay. Under draw. There's a sequence view. If you scroll down, there's a sequence view. And then you can select the structure that lies on the PDB. And then click on that. Okay? So now you should have the sequence on top. And then you can just go to residue 2. Or in this case, 1. But anyway, 1 or 2. You can go there, click on that. You're right there. Okay, if you're lost somewhere, you keep this up there. You can go anywhere you like. Okay? All right. Roughly in the right spot? Okay. So now we need to delete the waters first. So remember, so you do delete. Delete right here, lower right.
That refine, regulate, control panel.
No, you have to add terminal residue.
No, sir, that will delete window. That refine, regulatize, control window.
You're there, right? You're variant 2.
Yes, sir, I'm
You can add a terminal residue to it.
terminal residue.
Add terminal residue. So that's one of the that icon. You don't have an icon here. This icon. So if you're not good at Coot, like me, I suggest you keep the text here too. Many of you only have icons. I have no idea what the icons are. So please keep the text as well. Do you know how to do that? If you don't know how to do that, let me show you. So under edit, so under edit, okay, at the very bottom, there's preferences. Okay. Let me see. Are we okay? Under Edit, there's Preferences. Under Preferences, there's a Refinement Toolbar tab. You click on that. You select on the right, icons and text. Got it? So that way, you have the text too. Because when I say things, you look at the icon, you have no idea. I have no idea myself. That's why I always have the text on. My students are much better than me, so they have only icons. One of these days I may get there, but I'm probably too old for that. Anyway, so this is sort of what helps you. You have icons and text. So when I tell you something, you can look for the text. Okay? So, good? All right, when you're happy with that, just say, okay, I'm not gonna do anything, so I'm gonna cancel this out. Okay, if you have to say okay, otherwise you will not save.
How to get the text?
Oh, so under Edit, Preferences. At the bottom is Preferences. Okay, and then there's a Refinement Toolbar tab. Click on that. And then lower left is where icons only, which is default. I hope they change the default, so default icon plus text. But anyway. Okay? All right. So now let's delete the waters, as we showed, because otherwise we can't refine. The water is occupying. So we'll go delete. So now you know where delete is now, right? Because it says delete. Okay? So click on delete. And then another window opens up. And it says residue or monomer. We don't want to do that. We want to delete water. So click water. Select deleting water. And then we're going to delete more than one. So at the bottom it said delete that, keep delete active. Click on that as well. So that way, after deleting one, it doesn't disappear. Okay? So now we're ready. Come back to the graph window, click somewhere, and then just click on the waters. Okay? Yep. So in this case, they're all gone. Did you succeed in doing that? Good. Good. Got it? In the back? Are you guys okay in the back? We're all good? Moving on? Okay, so when you're happy with what you did, close the window, okay? Because otherwise delete is still active. That's very dangerous. So close the window. So now we can do real space refinement, start dragging around. Okay, for that, you click on real space refinement, which is up here, the very top one. Okay? Delete the water. So you go delete, and then select waters, and then say keep delete active. That's at the bottom. And then you go back to the graphics window and click on the waters you want to delete. Got it? Okay. So now we can refine this residue into the density. So to do that, you click on Real Space Refine Zone, which is at the very top. And then it's a zone, so you need two residues. But the two residues can be the same residue. So in this case, we're only going to do the residue one, because that's the only one we're going to deal with. So just click on this residue twice, anywhere. So it did the refinement already, but it's not happy because of course it's not happy. The cyclin is complete out of density, and then it should be over here. Okay? So now you can start dragging. So you put your mouse on the atom, hold the left button down, just drag. And you know where to drag, I assume. Drag it into the density. Try it out, see whether it works. Real space refined zone. And then click on the lysine twice. And then you can start dragging it around. There should be a window that opens up. Drag it to the left, that tells you how things are going. Then you can start dragging. Let me walk around a little bit, see are you doing okay? You got it? Not too bad. This one thing is still yellow. So where's the lysine? I don't see the lysine. No, you don't have the lysine. Where's the lysine? It should be over here. Yeah. Did you build the terminal residue? This is lysine 2, right? This is valine, yeah. Valine 2, right?
Yes, sir.
Where's lysine 1? Where's your lysine 1? Did you build in the lysine 1? Anyway, you can build it in, and then, so this is where the lysine should go. So add terminal residue. Yeah, click on that. And then click on the valine. Click on the valine. Yeah, this way, yeah, anywhere on this. Yeah, there you go. Then mutate that to a lysine. Now you have it. No?
Change to lysine. How you can change to lysine?
Oh, you had to mutate it. So simple mutate. There's a just above simple mutate. There you go. No lysine? I see. So you're pretty far behind. Are you? So, well, go to edit, preferences, refinement toolbar, icon and text, and then say OK. That way you see everything. So when I tell you something, these are the commands. Okay? And then go to draw, sequence view, the protein. So you now have the sequence, click on valine, the first valine, and then zoom in. You know how to zoom in? It doesn't zoom in like that. So you have to know how to control your trackpad. This is the right button in the three-button mouse. So if you don't have a mouse, you don't know how to control trackpad, it's going to be very hard. So, okay. Okay. Go to edit. No, draw. You have draw. Draw. Right there. Draw. Well, which version of? Oh, using 1.1. I'm sorry, I don't know how to use 1.1. I see. You're using a different version of Coot. I see. So you have to somehow center on valine 2. So I had to learn how to. Yeah, this is 1.1. We are using 0.9. So it's a different version. Yeah. Okay. All right, that looks good. Yeah?
How do we get the sequence?
Get the what?
Sequence.
Oh, draw. sequence view. And then scroll to the right and click on the protein. Yeah, there you go. You have it now? All right. Yeah.
How to bring that residue lysine in that?
Right. So you basically, that's what we're trying. Oh, you fell asleep. You need to do a real space refine and drag it in.
Click that.
Yeah, and then click on it twice.
Click on that lysine.
Yeah, and then you can start dragging it.
But here it is not that thing coming out, like this green color.
Huh.
That's not coming up yet. Like how I can bring this thing in to that density?
Let me see. Oh,
In case
looks like you have something else there. What is that?
and after that it is getting crashed. Like
I see. Which version of Coot is this? 0.9 something?
yes, 0.9.8.
Okay.
Like this is the.
Oh, you still have a do you have a water there?
No, I removed that.
No, that's like there's a water right there. See? There's a water right there.
Yes, sir. Here you are.
Yeah, that need to be removed. Yeah. Okay, you need to open the map. No, file. Don't click. This icon only opens PDB files. So cancel.
PXE file.
This is only PDB, so you need to open the map. So file. No. File. Auto open MDZ, and then the MDZ file. There you go. And then make the map smaller. Edit. Edit. Map parameters. And make that 7. Yeah. Okay. Say okay. So now you can zoom in and then draw the sequence. Draw. Sequence view, and then go over. You can center the veiling. Click on the veiling. You center there, and then you have to zoom in. You know how to control trackpad to zoom in. The right mouse, the right mouse. Drag the right mouse. You know how to do that?
Yes.
Then you're good. Yeah.
After getting the sequence, what we have to do?
Click on the veiling.
Where? Which one? This?
Right. Click on it. So you're centered there. And you look around, you see the extra residue. Rotate around it. Yeah, see this is the lysine right here.
Lysine residue. This is.
Yeah, you build, so you add residue, add terminal residue to it. So where's your menu bar?
I'm not getting anything here.
Which version of Coot is this? 0.9? Where did you don't have a menu bar? You do. So go to edit. Preferences, bottom, and then refinement toolbar. So yes, icon and text. Okay, there you go. So now you can add that.
Now what we have to do?
Yeah, add the terminal residue to the lysine.
Terminal residue.
Yeah, to the valine. Click on valine anywhere.
Here?
Anywhere on the atom. Yeah, so there you go. So now it's an alanine, and now you can do mutate, simple mutate, right here. Click on the atom.
Same item.
Any atom, yeah. Nope. You click twice. Single. Try again.
First we have to
No.
simple mutation.
Simple mutate only. Yeah.
Simple.
No, you have both selected. Just click somewhere else. Okay, I don't know what's going to happen now. Let's see. Click on the alanine. No, that's valine. Click on here. Yeah. Okay, there you go. Select lysine. There you go. So then you should have it. And then you can do.
What has just happened here?
Well, let me see. Oh, he built another residue for you. So you can delete this residue, I guess.
This?
Yeah, you can delete that one. So delete. and then that's fine. Come here, delete, click on delete residue. That's fine. Don't close it. Delete. Come here, click on No, the atom, not the water. Click on this carbon.
This one is the water.
This one, no. Right now you're deleting because you build the extra residue. Delete the residue. Don't delete that one. So delete this one too then.
So I deleted this.
No, you have to delete this one now because this is the wrong one. You want to delete again. Okay, so delete. Delete this one.
This one.
Right. And then mutate that one.
This one.
Yeah, mutate that one to a lysine.
Simple mutation.
Yeah.
Simple mutation. This one.
And single click. Don't double click.
Lysine.
Yeah, single click. So what happened? Did you double click? Okay, let's see what happened. Turn a little bit, see whether you have the side chain. No, turn. Just turn. No, don't build another residue. No, you lost everything again. So what's going on here? Yeah, delete that. Build the lysine. So don't double click. Single click. Single.
Just a second.
Single click. Don't double click. Yeah. All right. So, did you have luck dragging things around? Were you able to fit it in? No? Okay. Let me see. Did that work? Yes? Did it work for you?
Yes.
Something like this? You can see the electron density map is zigzagging, and the chain is zigzagging too. So it's a very good fit. The amide nitrogen is in this big bulk density, and the bond is the amide bond to the next residue is there. Got it? Okay, let me look around again, see how many succeeded. Turn a little bit. You're looking at the arginine. Oh, you build the arginine in?
So I have used this mutate. Like, I have added the arginine by. Like,
So which residue is
how
that?
can
Residue
I
2?
remove this? Like if I add it by simple mutate, like here I am adding
Which residue is this?
arginine.
No, which residue number? It's the valence. Right? Residue 2, right? Should be a valine. Turn this a little bit. Turn.
Turn.
Yeah, without a mouse it's very hard. Okay. So you're okay?
The Coot window is unexpectedly closed. After choosing the real
Did you build the lysine in?
No, sir.
I see. Are you on the valine?
Closed unexpectedly.
No, center on the valine. And then,
Starting again.
right, build the lysine. Add terminal residue. Yeah, click on any atom on the valine. No, click on the atom. Don't click on the density.
This is very.
Did you select add terminal residue? No, add terminal residue near the bottom.
Terminal residue.
Right. Select that and click on this.
So what to select?
Just click on the command and then, okay.
Click it.
Click on this, yeah.
Yes, sir.
And then go over here. Click on, yeah. Right here, so you build something. And then mutate that to a lysine.
Sir, this is also this is alanine.
This is an alanine right now. Mutate to a lysine, so simple mutate.
Mutate.
Yeah.
Then I have to click again in atom on atom.
Yeah, on the any atom. And then, okay.
Whatever the recipe I want to mutate, I can.
Okay, so I understand what's, all right. So please, everybody, please stop. I think everybody's everywhere right now. So let me start from the beginning. Let's all start from the beginning, and then we all go slowly, one step at a time. All right?
Yes, sir.
Please follow me. Pay attention to me. After you build the first one, you can do anything you want. I don't care anymore. Let's get the first one right. Okay, so please, let's start from the beginning again. So I'm going to kill my Coot. I'm sorry. Doesn't sound good.
Sequence started from the valley, not from the alanine.
Sequence.
Started from the valley, sir.
Valine, yeah. So follow me. So please, everybody, pay attention because it's too many ways of doing things now. It's dangerous now. Okay? Okay. All right? Everybody, please have a clean slate. Let's start at the same place. Hopefully you end at the same place. Please pay attention. I'll slow down. Every step will wait for you to say yes or no. Okay? So start Coot. All right, so everyone should have a menu bar on the right with text, okay? Not just an icon, with text. And then the menu bar on top should also have text. So everybody good? Yes. Thank you. Speak up, please. Because otherwise I don't know where you are. Please help me, okay? So, good? Yes. All right. Let's open the PD file. So now you can use the little folder icon on the upper left. And then lysozyme.pdb. You should have fewer files than me, but anyway, this is the file you open. All right? So you should have something like this. And then some of you probably see these blue things on the side. Do you have, if you have those, like me, we can turn them off. Okay, I'll show you. If you don't have it, don't worry about it. If you have it, turn it off. I'll show you how to do that. That's under Draw. Okay. You're behind already, or you okay? All right. So under Draw, and there's a command called Cell on the Symmetry. Right here. Okay, go there. And then the little dialog opens. And then just say symmetry off. Click on symmetry off. And then say OK. And then that should disappear. Good? We are still on the same page? Yay. OK, now let's play with colors. Let's change the color of these things. Okay, are you paying attention to me? If you're not with me, please speak up so we'll wait for you. I don't want you to fall behind. Good? All right, so to change the color, edit, bound colors at the very top. Okay, and then change the scroll bar to 0. That makes the carbon orange. he wants to learn too, so what can you do? Okay, so that's what you have as well? All right. Now let's open the electron density. Okay? So that you cannot open with the file icon. The file icon only opens PDB files. It does not open electron density. So for that, you have to go to the file menu bar. So file, auto open MTZ, the second option. You see it? Okay. Click on that. And then you go select lice01.mtz, which should be in your folder. Okay. When you have that, say open. And you have something like this. And then if your map is bigger than mine, you can reduce the radius. So how many still have a bigger map? Okay, good. Thank you. So go to edit. And then map parameters. So the menus are alphabetical, so you know where you are. So go to map parameters. Okay, the very top one, map radius X-ray. You probably have 16. So change that to 7. Okay, and then say OK. Good? Got it? Okay. So that's the first thing we do. Second thing we do is change the contour level. And that, remember, middle wheel, spin the wheel until it's 1. Got it? So a number should show up at the top. It says 1.00 or somewhere around there. Oh, that's the middle wheel. The middle wheel on your mouse. Spin the wheel, and then this will show up. Got it? No? Uh-oh. All right, that's good. And you're not spinning the wheel. You have to know how to control the middle wheel. So, all right, so I don't know how to do the trackpad. But then you don't have a mouse now. Yeah, try it out. You'll see. Yeah, okay. And now he'll give it back to you. Everybody else okay? Yes. Okay, good. Good? Yes. All right, thank you. No. So were you able to see the number change when you spin the middle mouse? Middle wheel, sorry. The number should change. $1.00. 1 sigma. 1 sigma, that's sort of the noise level. The noise. So you're contouring at the noise level. So things below it will be the noise. So you got it? Okay, all right, so moving on. Okay, next thing I guess we'll do is change the color because that's a little bit dark. So go to Display Manager. Okay, at the top, Display Manager. Click on it, drag the window to the left. And then under map, the first map, you should have properties, right? Click on properties, another window opens up, scroll down a little bit, you see color. Okay? and then click on color. You see this tricolor wheel, and then I'll make it cyan because it's bright. So click on the cyan region of the circle, and then make see the little black circle right here. That tells you how bright you are. So I usually click here to make it really bright. If you want it darker, you can click over here. That will make it black, like you can't see. So I'll click on here. So you use the wheel to select what color you want. Use this black circle to select how much saturation you want. Okay? So right here. And then when you're happy with it, say OK. And say OK to the dialog box as well. So everybody OK? Thank you. Okay, so next thing we do, we display the sequence of the protein. Okay, so say draw. Sequence view. And then just click on the protein. Okay, so the draw menu, sequence view, and the protein. That was under PDB. Okay? Click on that, and then sequence view should show up. Do you see that in yours? Everybody has it? Yes. Thank you. Now we go to valine 2, the first valine. So you can see the residue numbers on top. So the first valine, just left click on that valine. Okay, you should be centered there. So next thing you do now, so this is too far away, we cannot see much. So we need to zoom in now. To zoom in, you drag with your right mouse button. Okay, so right drag. You have zoomed in now. Everybody good? Thank you. Everybody good? Yes. Okay, so now we're going to build another residue in front of it, right? So we'll say add terminal residue right here. Click on the menu, add terminal residue on the right. And then go in, click any atom of the valine. Click on the atom. Any atom. Okay, so click on it. So I'll click the C alpha. So now you see a residue got built in down here. You see that? You see yours? Everybody good? No? Okay, what happened?
Residue.
Did you click on build residue? Add terminal residue.
Yes, terminal residue.
And then click on anywhere. What's going on? Maybe that's something connected to it. Let's turn it a little bit, see what happened. The other way. Zoom out a little bit. Right drag. No, drag. No. Yeah, right drag. See, there is something connected to it. It is built in. You just zoom in too much. Zoom out a little bit.
Zoom in.
Out.
Zoom out.
No, that's change the right button. The other way. There you go. There you go. You have it. You zoom in too much so that everything got clipped out. Yeah.
Add terminal residue.
Click on anywhere. Yeah. You probably have it too. Turn a little bit. Turn the structure around a little bit. Yeah, you have it. So you zoom in too much. So it's right there. You see a bond connecting to it. This is the zoom out, slide out. Yeah, there you go. You see it now, right? You see right here.
This one.
Yeah. Turn a little more. There you go. Okay, so if you zoom in too much, you may not be able to see it. So if that happens, you zoom up a little bit, you see the alanine built in. So
Added two. How can we have added?
yeah, that's the residue. Oh, I'll show you. Okay, you have it. Hold on 1 second. So everybody has it? Yes. Thank you. So now we center on the new residue built in by doing shift, holding down shift and spacebar at the same time. That move backward residue. So hold down your shift key and spacebar. So now you're centered on the first residue you built in. Got it? No? You build a, okay, so hold down shift and space. Yeah, there you go. Okay, so roughly, we're all together? Yes. All right, thank you. So now we have 4 water molecules. So maybe you can rotate things around so that it looks something like mine. So main chain this way, side chain going to the right, to the left. If you want to do it that way, that's fine. You can see the 4 waters here, 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 and here that we need to delete. Okay? That's the next thing we're going to do, delete the waters. So for that, you go to delete. All right? So delete. And then we're going to select delete waters only. Okay? So select water. And select keep delete active at the bottom, because we're going to delete 4. Otherwise, deleting 1, the panel disappears already. Okay, so select that to be active. And then go back to the graph window, click somewhere. Now you're in the graph window, now you just go click on the water molecules one by one. All right? 1, 2, 3, 4. Do you have it? Everybody good? Yes, sir. Thank you. All right, so now we're done. We close that panel, okay? Because we don't want to delete other things. So let's just close it, say close. So next thing we do, we know it's a lysine. Right now it's an alanine. So we're going to change that to a lysine. So we'll do simple mutate. Above atom residue, simple mutate. Okay, click on simple mutate. And then click on any atom of the first residue, any atom you want. So click on C alpha, for example. And then you should see a dialog. You can select one of 20 amino acids sorted alphabetically. Do you see that? Okay. Oh, you're ahead of me. That's okay. So lysine, happy with that? Lysine? Okay. And now you should see the side chain staking out. See that? Everybody has it? Good. Now let's do some dragging finally. Okay, so now we need to bring this into the density. Density is here, side chain is here, obviously not happy. So when you do a real space refined zone up there, click on that. And then you can see the command selected when that thing turns pink. So now it's a zone. It's a zone of 2 residues, but it could be the same residue. So click on any atom twice. That defines the zone as that residue. Okay? So I'll just click on C alpha twice. And then a little window opens up. So drag it to the left so you can see it. So now It did some refinement, but obviously not correct. So now you can start dragging. Just put your left mouse on any atom you want, and then drag. So if you see the ammonium ion at the end, click on that, and drag to anywhere the density is. Then you should fit it in. So I'll wait for you. You got it already. Oh. Let me know when you're done. Done? Shaking head means yes or no? That's yes, right? Yes. Oh. I need to learn. So yes is this, no is that.
This is yes.
Oh, this is no. This is yes. See, I'm doing it the wrong way. Okay, are we all there? Are you happy with the? So everybody did it? Yes. I haven't done it yet, so wait for me. Drag. Oops. Well, not very good, so I need to do some more. There you go. So now it fits very nicely. You can see the nitrogen sits in its spherical density, and the cyanogen zigzagging along the way. So we're all happy with what you have? All right, better say accept. So that way you accepted this model. You're good? All right, congratulations, pat yourself on the back. You built the first residue. So I think we're done. Okay? So that's what we do. And we'll do a couple more, just for fun, okay? So we built the first one. So we can go to the next one just by placing spacebar. You press spacebar, you go to the next residue automatically. Okay, so try that. You should go to variant 2. Got it? Okay, so that's one we looked at already. But do you want to do the rotamer thing, the side chain torsion angle, all that stuff? Do you want to do that? If you want to do that, we can show you. If not, we'll move on. Huh? Do the rotamer thing? Yes?
Yes.
Yes? Okay. So for that, let's hide the electron density. Okay, to do that, to hide electron density, you go to Display Manager. There's a little check mark in the front, display, right there. Just check them, click them off. Then the electron density map is gone. Okay? Do you see something like this? No electron density. So the two check marks right here, that controls whether you see the map or not. All right, so let's look at this valine. So this is the C alpha C bond and then the two methyl groups. So right now they are trans, right? So we can twist this C alpha C bond torsion across it. And to do that, that's called, that's a chi side chain angle. So add the chi angles on the right. So click on that. Add the chi angles. And then again, it's selected as pink. And then go click on any atom in variant 2. So, and then little dialog shows up, drag to the left. And then it gives you a few options. And we're going to do chi 1, which is the C alpha C beta bond. So click on that, select it. So that should turn green, I believe. Yeah, well, when you select it, it turns green. Let me see. Okay? Yeah, so now it's so the bond you can see is green. You see that on yours? The C alpha C beta bond should have green. Am I losing you already? Good? Good? You're good? Okay. Now understand, this way means good. All right, so you have it. Go back to the graphics window, and then just drag your left mouse. You see the sidechain torsion? Do you see that? So you can drag it so that it's completely cis to the main chain. That will now be happy, right? And you can also change the view. When you drag the left mouse, you only change the chi angle. But if you do control drag, then you change the view. Okay, so this is something that's very common in Coot. If you do selection, the left button only does the selection, but if you do control left button, you change the overall view. So you can change to any view you want by doing control. But anyway, so this is sort of how you choose different chi angles. The actual chi angle is shown up here as well as you drag around. You can see the chi angle is up here as well. It tells you the chi angle, but that doesn't matter too much. It's basically what you see. You got it? Yeah, yeah, select that, maybe click it twice. Yeah, and then go back here, go back here, graphics window. Click on somewhere in the graph, no, just don't close it. Go back to the graphics window. No, no, you can't go out of this? Yeah, click on that. So you have to maybe drag this out of the way a little bit. Drag this out of the way to put it to the left.
So how to drag here?
Drag the top. Yeah, there you go. So it's the wrong button. Oh, there you go. So now you can drag your left mouse. Yeah, drag. There you go. It's turning. Drag around more. There you go. Yeah, a mouse will be much better. Okay, are you happy with the exercise?
Yes, sir.
To just show you, you can twist the sidechain conformation around. You can sort of see this is not a good conformation because these are clashing. And that's a good conformation because it's not clashing. That's the idea. That's the concept of rotamers. Sidechain, yeah. Yeah, sidechain. Okay? So if you're happy with the exercise, then go back to this and say cancel because we don't want to keep it. We just say cancel. You don't want to apply because if you don't, in the end, you don't want to save anything, just say cancel. You do go back to where you are. Okay? All right? So that's how you change sidechain angle manually. And then to select rotamers, there's a rotamers command. Okay, so click on rotamers. Are you with me?
Yeah.
Okay, click on rotamers. And then again, click on any atom on that valine. Another window shows up. It tells you valine has 3 rotamers. 73%, 20%, 60%. You have something similar?
Yeah.
So the 73% looks like this, very similar to our structure. So that's the preferred rotamer, which makes sense because it's fully trans, right? Now click on the second one, see what happens. Just click on the little button in the front, click on that, this changes, right? And then click on the next one, it changes to the third rotamer. So valine has 3 preferred conformations for the sidechain. That's what these are. So that's the concept of rotamers. Everybody good? Okay. So again, we're not going to save anything. So go back to the window, say cancel. Okay. If you have it, then you can save. But right now we're playing around, so just say cancel. We don't need it. Okay, let's turn the map back on. Which I'll just turn on the first one. You don't need to worry about the second one today. I'm not going to go in there. So here we are. We're still on residue 2. Let's do one more dragging and then we're done. Okay? So spacebar again. You're residue 3. Are you a residue 3? Phenylalanine. Yes? So, yes? No? Yes? Okay, all right, so this looks good, right? Everything looks good, phenyl ring, everything's similar density, so we don't do anything about it. So we'll move on to the next one. Next one is a glycine. Well, not much we can do. Main chain looks good, side chain, no side chain, so it looks good. Don't need to worry about it. Right? Okay, next one, spacebar again. So this one is an arginine. So main chain looks good, side chain looks good, except the guanidinium. So, but that's, let me turn around a little bit. In this view here, you can see guanidinium goes this way, the density goes this way. In this view, the view I have. So that means this need to flip around. This nitrogen need to be here, that nitrogen need to be there, right? It's very clear, the density tell you how to change the model so that it fits. So how do we do that? Well, let's play a little bit. You like dragging, you can drag if you want. Let's try something. Let's say autofit rotamer, see what happens. I don't know what will happen. I never tried, so let's see what happens. So click on autofit rotamer, and then click on any atom on the arginine. What happens? I don't know. Let's see. Oh, you got it. Did it work for you? Yes? You're watching. That's fine. Huh? Oh. Okay. You okay? Back there? Everything good? I'm almost like a salesperson. I'm selling Coot here. You can take it home and cook it. Okay, so I think I gave you a flavor how to build things. But obviously, it's a very powerful program, many options, many commands, many of those I don't even know myself. So I'm learning along the way. I've been using this for 10, 15 years now. I'm still learning. But what I know is enough for me to get around, so it's okay. May not be the best way, but might be a few seconds slower, but enough to get me around. So that's fine. And for you, same thing. So now you get a flavor. As I said, it's a steep learning curve, but I'm happy to see that we are now on the same page. So you are at least making inroads into this program. So practice makes perfect. So now you have my primer, all that stuff. Play around. I'll be here for 2 more days. So if you have questions, grab me. I'm happy to help. Okay? So, and I think that's all I'm going to say about Coot today, in the interest of time as well. But would you like to see a beautiful picture? Yeah. All right, let's do that. So go back to the display, delete map. On the right, delete the map, both map, delete them. And then delete the model as well. Okay? We don't care about lots of them now. Okay, so now we have a blank slate. So now you'll say file, no, you can open a PDB file. So you can use the little icon. And then 7W7L should be in your folder, right? I put that in yesterday, so you should have it. Do you have it? Yes? Okay. Do you have it? So if you have it, please open it. Okay? So should look something like this, right? This is what you have. I'm sorry. Yeah, click on this. And then 7W7L. Right, you should have it, right?
Yeah.
Yeah, open that file.
Which one file?
7W7, should be in Coot.
Coot.
In the Coot folder.
Okay.
Right here.
Then
7, yeah, right there.
PDB file.
Yeah, that file.
Where?
In Coot, let me see. Is it the Coot folder?
When Coot.
No. The Coot folder that came from Professor Shukla yesterday.
Okay. Yes.
In that directory. Huh? Did you find it?
Yeah.
Yeah, open it.
This one.
Yeah.
PDB.
Yeah, zoom out. Yeah. I see. So, huh? It's zoom out. So it's in the same folder as the lysozyme files. Okay? Everybody found it? No? Shaking head means yes. Okay. Okay, are we good? Yes. Okay, so one more thing we're going to do. So this is very complicated. So let's make it simpler. We'll do something called a C-alpha trace. So under display, you see display style right here. Right now, display as bonds. So there's a drop-down menu. Click on the drop-down menu. And now you should see an option called C-alpha plus ligands. So that means for each residue, display only the C-alpha atom. So much simpler structure, so-called C-alpha trace. So click on that. So now you see the protein, RG-like fold with the DNA bound in the middle. See something like that? No? Okay. Sorry. Under display, click on this drop-down menu. Got it? And then select C-alpha plus ligands. Got it? Okay? Okay, so next thing we do, so have something similar to this? Okay, so go to draw, and then cell and symmetry, this one right here. Okay, got it? So another window opens, drag to the left, and then say symmetry on. Okay, got it? And then there's a symmetry by molecule button. Click on that button. And then another menu shows up. Say display as C-alphas. See that? The bottom of the left column. You see it right here? Display as C-alpha. CA means C-alpha. Got it? Okay. Click on that. And then say OK. All right. And then also over here, we're going to say unicell. Show unicell right here. Right here. Show unicell, say yes. It tells you the unicell of your crystal, but that's OK. So zoom out until you see something, a little diamond like this. You see something similar to this? A diamond. One single diamond. You have to turn. If you don't see a diamond like this, turn your structure around until you see a diamond. Bless you. Turn. Keep on turning. There you go. You see it. Turn up. Turn up. No, turn. Don't zoom. Turn. Zoom out. Zoom out first. Zoom out. More. Zoom out. More. More. Yeah. Turn. Now you're 90 degrees away. Turn up. Turn up.
I think we have to do
There you go. Getting close now.
like that.
Yeah. Close. Okay. It shows CF trace under display. Where's your display? Display bar here. Yeah, zoom out, zoom out more. You can see this. Yeah, zoom out. Good, good. Make it as close as possible, okay? All right, have it. So now go back to this panel here. Make the radius 70. Right now it's 13. Make it 70. And then say OK. Do you see something like this? But not that beautiful, right? I said a beautiful picture. Overpromised. Okay. Now let's go back. Say, go back. Reopen that window. Let's make that 150. All right. What do you think now? Do you see something like this? Good. Anyway, so the idea, this is just showing you how the molecules are packed into the crystal. And in this case, the packing is so beautiful, almost like a church window or temple window or something. Very beautiful patterns here. And I guess I changed things a little bit, so. There you go. So let me make that a little bit bigger. So I made mine a little bit bigger still, so you can see the pattern, very beautiful pattern here. That's the whole point. So you don't have to, you probably see something similar, not exactly the same, but that's okay. So this is sort of show you how molecules are arranged into a crystal lattice, and that's sort of beautiful pattern like that. Okay. So you have something closer, similar to this, is fine. If not, you can play around when you have time. Okay, so that's it for Coot, I think. All right? So we'll stop Coot. So what should we do next? We have half hour, so do we do PyMOL or do we, I guess I have to show PyMOL, otherwise you can't follow me. But PyMOL's, you want to say something? Okay. So, but PyMOL you're more familiar with? Right? Okay. But importantly, which version of PyMOL are you using? Okay, all right. So this is the folder you have, right? The PyMOL folder that I gave you yesterday should have these files in there, right? So PyMOL, just double click on the structure, 7RFW, which is this one here. This one here, 7RFW. So double click on that to open PyMOL, or whatever way you want to open PyMOL is fine. 7RFW. So here's PyMOL. So you all have it? Okay. So I'm using 3.0.4. So you just go to PyMOL, about PyMOL on a Mac. On a PC, I don't actually know. But anyway, this is how you find out which version of PyMOL you're using. So are you using version 3 or version 2?
Which one we have to open? 7 RF.
That's version 2 or 3. Don't get, just say open. You have the PPT file. Oh, sorry. Just say open, file open, and then select the file. Just open it here. Yeah. And then you go to the PyMOL folder and then find the file. So this is the PC. Looks like which version of PyMOL you're using? Do you know? Looks like version 3 to me. Okay, good. Good. Which version? No, these are so most are using PCs. Oh, interesting. Okay. All right. Yeah, just double click on the PDB file, it should open.
I have opened PyMOL and no file will be shown here.
What is it? What? It is PyMOL.
Yes, sir, this is PyMOL.
Hold on, let me see. I can't read that way. Sorry. Where did it go?
I have tried 3 times to open that file, but it didn't open this one.
Desktop में सेव कर लिया
Huh. I don't know. Maybe try to. You open 3 times, so there are 3 states already.
No, sir, it is not opening after one time. First time it is not open.
I see. Okay. I'm not sure what's going on there.
Is this the version?
I don't think so. You should open. So you cannot open any files, or only this file you cannot open? Really? This file came from the PDB. It should open. Okay. Oh no. Okay. So what do we do? So how many of you are familiar with PyMOL? Reasonably familiar, let's say. A reasonable number. So I guess we had to start from beginning.
Yes, sir.
Somewhat from beginning. So same thing, left mouse drag around, you rotate, and right mouse you zoom in and out. And then the middle wheel you slab, you cut things out. You turn the wheels, and your structures start going away or coming back depending on which way you're turning. That's called slabbing. You're cutting a thin slice, thinner slice of your structure. Okay? And then each structure, when you open it, It gives you a line here. And then there are 5 options on that line. Okay? So A means action, S means show, H means hide, L means label, C means color. So that's how they are labeled. So based on the letter, you know what's underneath that. You can click on that, it gives you the options. Just like Coot, we'll start PyMOL today, and then you go home to exercise PyMOL, and then tomorrow we'll try again. And then I'll figure out something to show the structures I talked about today. That's okay. I think it's more important for you to learn the tools so you can look at the structure yourself even. If you don't know the tools, you can't look at the structure yourself. So it's more important for you to learn the tools first, right? Do you all agree with that? Okay, so there's a PyMOL primer as well. Have you looked at it? I mean, I spent a lot of time writing it, so you better pay attention to it. Just kidding, right here. So look at that. And sections 1 and 2 are general commands about PyMOL you should learn yourself. Section 3 is the structure, which is a SARS-CoV protease bound to a ligand, which is a drug on the market against SARS-CoV. So that's the idea. But today, let's just do something to get you familiar with it or get you started. So then you can learn more on your own as well.
Sir,
Okay? Yeah?
sir, you in the primer document,
I'm sorry?
in the document you have shared the PyMOL primer.
Yeah, you should have it.
Yes, sir, I have. There is that molecule you asked a question in that the cysteine residue 1,3 interacting with the ligand.
Which structure is this one?
Sir, that 7RFW.
So, okay.
This is the ligand.
No, it's not the ligand. Why is it pink?
I
Oh,
think
that's
the
a,
color-
oh yeah, that's a that's a ligand. Yeah, that's
And
correct.
You asked the question to check there is cysteine residue 145 in that protein,
Uh-huh.
and it is interacting with the drug molecule.
Right.
What does it mean?
I mean, why is it interacting this way? It's a covalent adapt. So the covalent inhibitor. The enzyme attacks the inhibitor from the covalent bond. That's what that means. So that's a cysteine.
Yes, sir. It is.
Yeah, it's a cysteine protease.
Yes. Okay.
So the cysteine active site attack the inhibitor from a covalent bond. And that's how the compound binds to the enzyme. It gets stuck on there, covalent link. Yeah, good to see that. I'm gonna show that. You jumped me already. Okay. So let's play around a little bit, okay? So here you have the structure shown as a ribbon or cartoon drawing. That's the terminology in PyMOL. You have little red crosses. You see that on your screen, little red crosses. So those are water molecules. And for simplicity, let's hide them. We don't want to see them. So how do you hide them? You hide, go to H. That's hide. So click on H. A long list of things shows up. You can't see in the back. You have to look at your own screen. And at near the bottom, you have waters. So, and then select waters. And then you see they're all gone. Right? Hide waters. Okay? And then everything's shown as a cartoon drawing except there's some sticks here. And that's the inhibitor. Inhibitor has little things sticking out. Those are hydrogens. And we can hide the hydrogens as well. So since we're looking to hide things, let's hide hydrogens. So H again, go down. You should have hydrogens. And then it has arrow means it's more selection. So click on go to hydrogens. Don't click on it, or if it doesn't happen, nothing happens. Rest your mouse there, more options appear. It says all or non-polar. Let's just hide all of it. Okay? So, okay. So now the hydrogens are gone. So now we see only carbon, nitrogen, and stuff. Good? All right. So now, turn your structure around so that it looks something like this, let's say. Okay? So the inhibitor at the top, you have one domain here, one domain down here. How do we know that? Well, you can, this is PyMOL. You can color things in many different ways. You can color the structure as a rainbow. How do you do that? Color. So you want to change the color? Say color. So color, spectrum, and then over here, rainbow. So don't need to click. When you have something on the right arrow here, that means there are more options. You rest on it, and then another submenu appears. Okay, click on rainbow. Got it? See something similar? Okay. So what does the rainbow mean? It means blue is N-terminus, red is C-terminus, the last residue. Okay? So that's basically how PyMOL ramps from blue to cyan, to green, to yellow, to orange, to red. So that's how you can walk down the chain.
How to know about the N-terminus and C-terminus of the
I'm sorry, about what?
How to know about the N-terminus and C-terminus?
Oh, that's how do you know? By the residue number.
Yes.
The smaller number is N-terminus, larger number is C-terminus. So the PyMOL just ramps based on the two numbers. Okay, good question too. So you want to know what residue number that is? You click on it. So click on the blue, the blue thing. Click on it. Okay? And then there should be a little window you see that tells you that's residue 1, serine. Do you see that on your screen? Should be in this little command window here. So it says you clicked 7RFW, that's the object. Chain A, serine 1, C alpha. Huh? You mean just click on here, right? It should show up, it should echo what you did down here in your command line, command window. And then it tells you which one you clicked. You see that? You got it? Just kidding. Okay?
Yes.
In addition, you see when you click on something, you see little purple squares show up. So that shows that this residue you have clicked on, this is being selected. And that shows up as another object here, select. So you can play around with it too. So for example, this residue you clicked on, you selected it. So now we can say, okay, well, I want to show this residue as a sticks drawing. How to show something? S. Okay? So show on the select thing, okay? Not this. This will show everything. On select, only the one you selected. Okay? So say show. What did that do? Okay, select. Oh, I know. Show sticks. So now you see sticks on that residue. Well, it's blue, unfortunately. So you click somewhere else, the selection goes away. You can sort of see the residue being shown here. Okay? Are we sort of on the same page? Okay. So now we're tired of the rainbow. Let's go back to a different color. Okay, so color. Go back to the entire molecule. You say color. You can color many ways that you see on your screen. You can color by chain, by secondary structure, by whatever. Let's say color by element. Okay, so CNOS. So color by element. Again, a menu shows up. You can have many options. And let's color as the second one where the carbon is green. Okay, just click on that. So the entire structure is green now again. Now you can see the residue better. Right? Okay. So this is all good, right? Let's play color a little bit more. So this is the protein. The inhibitor is up here, the stick model. That's green as well, doesn't stand out. So let's give it a different color. So you click on the inhibitor, anywhere on any atom on the inhibitor. So now you see little squares on all the inhibitor. You see that? So that means you have select inhibitor. That means the select here now is the inhibitor, no longer this residue, but that one. So now you can color it by element. So let's say color by element. What color do let's do cyan. Is that better? You see something similar? Good? Okay. So let's do something else. So this is the protein. It has a molecular surface. You know about molecular surface of a protein? The surface features. So we can show the surface as well. PyMOL can do that. So how do you show surface? You go to show. That means S. So go to S. And then scroll, look down, you'll see surface right here. So click on that. You see something like this? What? Oh, you're still here. So show under show. So under show on this. No, on the other one. Under S, surface. Yeah, scroll down until you find surface.
इसमें करना है 7R.
Yeah.
We need to leave.
Right now, or
Yes. In
I
2
see.
minutes.
Okay, we'll do one more thing.
Yeah, they can do.
Yeah.
Okay, we will.
I see. We need to go. Okay. All right. Okay. Anyway, so when you get it, you can sort of see there's a nice pocket here, right? You see a pocket?
Yes, yes. You can see the pocket.
Anyway, please practice. You see a pocket where the compound is bound. And then I guess I understand I have to leave. So we will continue with this tomorrow. Tomorrow afternoon, I think we'll have time tomorrow afternoon. So but please look at the primers I wrote. Look at the first and second sections so you know what it looks like, how get familiar with PyMOL, and then section 3 is what we are doing right now. Okay? All right.
Okay, so and
Enjoy.
one more thing, you can keep your laptops in the smart classroom if you want to practice more, because collaborative learning will be better, I think. Okay, so another few